So very good afternoon, students. So here I am with my third experiment. The name of the experiment is the volt ampere or VI characteristic of Zener diode. Okay. So what actually we are going to do is we are going to firstly plot the VI characteristic of Zener diode in reverse bias condition. We will find the Zener breakdown voltage in the reverse bias condition, and the last part is that we are going to find the load regulation characteristic of the Zener voltage, as the Zener diode can be used as a voltage regulator. So Zener diode is basically a semiconductor device consisting of p-n junction. It conducts the current in reverse direction. When a certain specified voltage is reached, it has its reverse breakdown voltage. That means it can continuously operate in a reverse bias mode without getting damaged. It also conducts in forward biasing condition also. In the forward biasing condition, it is similar as the similar characteristic of the silicon diode, or germanium diode. But in the reverse biasing mode, we generally use this Zener diode because it can operate in reverse bias mode without getting damaged at a very high voltage also. It is used as voltage regulator. It protects from over voltage. It is used in clipping circuits. It is used to shift voltage also. So these are the materials which we require to perform the experiment. This is the theory part. So here the Zener diode have two types of breakdown here, Avalanche and Zener. So the Avalanche breakdown happens when both p and n side of the diode are lightly doped, and the Zener breakdown happens when p and n side of the diode are heavily doped. So this is basically the circuit for reverse biasing condition. We will use this circuit for performing these two things, part A and part B. We will plot VI characteristic in reverse bias, and we will find the Zener breakdown voltage also in the reverse biasing condition. Now for finding the load regulation characteristic, we will use the different circuit in which we are going to add a load resistance in parallel with the Zener diode. And we will change the value of RL continuously in order to check that whether this Zener diode act as a voltage regulator or shunt voltage regulator or not. These are the basic process. That how to find how to evaluate the above given things. Here is the formula of percentage regulation also. I will show you these things in Multisim. So now I am going to open the Multisim here. So this is the basic window of Multisim. This one is the breadboard, as you already know. So I am going to draw the circuit. Firstly, I am going to take the Zener diode. In the diode one, I am going to click on this Zener menu. I am going to choose this 1N4732A Zener diode. Now I am going to choose a resistance here. In basic part, I can choose a resistance here. You could choose 100 ohm, 1 kilo ohm, it's up to you. So here I could choose 1 kilo ohm. In this manual I have given it 100 ohm. So just see here, it is 100 ohm. So you better do with 100 ohm. I am going to do it with 1 kilo ohm. So now I am going for the source, the DC power source, or and now I am going to take the ground also. Fine. So now I am going to connect all these things. So firstly, I am not going to connect this ammeter, voltmeter. Firstly, I am going to show you what is the characteristic. We will directly evaluate it. Just we can also click on this interactive one and we'll select the DC sweep. Here the source is V1, just check it here. the V1 is the source, start value is 0. Now take step value up to 10 volt. Suppose here I can take 0.25 volt as an increment. In the output I will choose this ID1, that means the current across the diode. Okay, I am going to add this one. Now I am going to run this thing. So just check here, this is the DC transfer characteristic of this Zener diode. Okay, here we can look that after 4 volt or 4.2, 4.3 or 4.5 volt something, this graph starts to increase rapidly in the negative direction. That means here the breakdown has occurred. Okay, so now if you want to check the value, that what is the actual value at this point, we could directly export these values to Excel. Okay, just click on this one. We are going to trace ID1 only. Okay, and okay. So this will export all the datas here from here to Excel. Okay, so just look here, this is my Excel. So I am going to increase the width of this line. Okay, so here you could see here, this one is x-axis and this one is y-axis. So if you look here, that our x-axis is the voltage axis and the y-axis is our current axis. Okay, so if you look here, this voltage is increasing slightly by 0.25 increment of voltage, and here just look at the current. Okay, it is something like minus 6.03 to the power 10 into 10 to the power minus 12. Okay, so these are very low amount of current here. Okay, but if you will go downward, you will look here that at around 4.25, from 4.25 to 4.5, the current is increasing very rapidly, from 10 to the power minus 12 to 10 to the power minus 9 to 10 to the power minus 5, and here is the largest increment of 10 to the power minus 5. Okay, so we could say that approximately 10 to the power approximately 4.75 is the Zener breakdown voltage. Okay, so this, by the help of these two columns, you could directly plot the VI characteristic of the Zener diode in reverse bias condition, and here also directly you could check that approximately 4.75 is the Zener breakdown voltage. Okay, if you want to find the exact value, I will tell you that how you can do it. Just delete this thing. I would check the voltage across this Zener diode. Okay, I know that approx 4.75 volt should be the Zener breakdown voltage, so I would give voltage more than 4.75. okay, the input voltage should be more than 4.75 volt. So here it is 12 volt, so it is okay. So I am just going to use here a voltmeter PR1. Okay, so now I am just going to check the value of this voltage, that what the voltage is. So I am going to click on this DC sweep. I will click on this interactive simulation and I will run it. Okay, so just by running it, just see here what it is showing. It is showing here 4.65 volt. Just look here, the voltage is 4.65 volt. When the voltage is 12 volt here at the input side, the voltage across this Zener diode is 4.65 volt. Okay, this value you can also find by the help of multimeter also. Okay, you could add multimeter here. Okay, and you could find the voltage from there also, or you could directly use this one to find out the voltage. So if I am going to change this voltage now, then also you will So if I am going to change the value of this voltage, if I am going to increase the value or decrease the value, you will see that this voltage 4.65 volt is not going to change. Okay, so just look at here. I am going to increase this value to suppose 15 volt. Okay, so look at here, the voltage across this Zener diode is currently 4.66, so it is approximately around 4.65 volt. So we could say that the approximate value of the breakdown voltage of this Zener diode is around 4.65 volt. Okay, which we have found out by the help of this these values. Okay, could also just use this data to plot a graph. Okay, I'm going to just show you a graph of this thing. So just see here, after 4 volt, 4 point something, we are getting a very huge peak down in the reverse direction. Okay, and the current is increasing at a very sharp rate, the negative current. Understood? Okay, so this one is the VI characteristic of Zener diode in reverse direction, and also we have found out that what is the actual reverse breakdown voltage of this Zener diode. Okay, so now we will move on to our next part. Our next part is to find out the load regulation characteristic of Zener voltage regulator. Okay, so for this kind of thing, what we do now, we do need to find out that at which voltage, at which input voltage our Zener breaks down. Okay, in the reverse bias condition. Okay, so for that thing, what we do need to do, we will just put one more voltage checker here. Okay, at this time when I am going to run this simulation, just see here, here it is showing 4.66 volt. Okay, and here the input voltage, it is showing 15 volt. Okay, so what we will actually do, we will plot that at which input voltage what is the voltage across this Zener diode. Okay, then we will add a resistor across this Zener diode, and we will check that whether this Zener diode is acting as a voltage regulator or not. Okay, so firstly I am going to check that at which input voltage this Zener breaks down. So I am going to firstly stop this simulation. I am going to click this interactive one. I am going for DC sweep. Okay, so the stop value is up to 10 volt, leave it to it. For output, the variables are PR1 and PR2. Just see here, I am going to check these two voltages, this PR1 and this PR2. Okay, so now I am going to click on this run thing. Okay, so I have got the graph. Okay, here it shows this PR1. This PR1 is the voltage across this Zener diode. Okay, and here it is of red color. So this graph, this red color graph is of PR1 and this green one is of PR2. So I am going to plot it. Okay, I am going to use both the PR1 and PR2. Okay, so it includes V1 and V2 also, this V voltage. Okay, look here, the Excel is open. Okay, so these two things, PR1 and PR2, I have wanted. This is my input voltage series and this is the output voltage of Zener. Okay, we could see here that approx at 7.5 volt the output voltage at Zener, okay, is around 4.62 and it remains like constant. Okay, 4.62, 4.63, 4.64. Okay. This means that around 7.5 volt to 8.5 volt, or we can say around from 6.5 volt to 8.5 or 9 volt, what happens, this Zener is breaking down. Okay, so at 10 volt we are getting 4.61 voltage. Okay, so in all these conditions we can see that the Zener has already break down, because the voltage across the Zener is not increasing. Okay, this means that approx from this to this voltage the Zener has breakdown. So we will choose the first voltage at which our voltage across the Zener became constant. So that is approx around 7 volt. Okay, 7 volt or 7.5 volt. So I am going to choose here 7.5 volt. So for the input voltage of 7.5 volt, I am getting that my Zener has breakdown already. Understood? So now what I am going to do, I am going to firstly close this thing, and I am going to change this voltage to 7.5 volt. Okay, so you need to find out firstly the input voltage for which your Zener breaks down. Okay, now when you will run this interactive simulation, just run it here. You will find that at around 7.5 volt this voltage across Zener is 4.62 volt. Okay, so now what I am going to do, I am going to add here, sorry, I am going to firstly stop the simulation, and I am going to add a resistance across this diode. Okay, a variable resistance. So here variable resistor is there, so I am going to use a 2 kilo ohm variable resistor here. I am going to connect it across this Zener diode. Okay, so now if this Zener diode acts as a voltage regulator, then after changing the value of resistances also, what happens, the voltage across this R2 resistance would not change. Okay, this is the basic implication of this voltage regulator. Okay, voltage regulator, what it does, it doesn't allow to change the voltage across this resistance which is joined across this Zener diode. So what I am going to do, firstly I am going to change the increment here. Okay, increment is 5%, so let it to be 5%. Okay, 5% of 2 kilo ohm is 100 ohm. Okay, so let it to be 100 ohm. I am going to firstly decrease the resistance here. Okay, just swipe it here. Okay, and run it here. Okay, so you could see here the voltage across this Zener diode is 150 microvolt. I am going to add one more volt checker here. Okay, so just check here, see here, we can see the voltage across this R2 resistance is 150 microvolt. Okay, so if I am going to change the resistance, just see here. Okay, if I am going to change the resistance across this Zener diode and this R2 resistance is changing firstly. Okay, now just see here that up to which factor it is going to change. I am going to click on the key A of keyboard. Just see here the voltage is changing regularly. Now we are going just at the part of the Zener breakdown. Okay, so at this thing we are seeing that here voltage came to be 4.59 volt, and here also the voltage of Zener diode is 4.59 volt. So actually the Zener breakdown is around 4.64 volt. So we have to choose a different resistor, so we could get here a Zener breakdown. Okay, so I am going to change the resistance here. So it is 2 kilo ohm here, I am going to make it 3 kilo ohm. Okay, okay, fine. I am going to stop it and I am going to run it again. Okay, so currently here the voltage you could see here. Okay, firstly I am going to decrease this one. Now just see here the voltage across the Zener diode and the R2 resistance. So the voltage across the Zener diode is 4.59 volt currently, and the resistance the voltage across this resistance R2 resistance is also at 4.59 volt. So we have already seen that here in the Excel sheet that at 7.5 volt or at 7 volt, what happens, the Zener breaks down, okay, and it further doesn't allow to increase the voltage much. Okay, so here also we can see here that when we have added a 3 kilo ohm resistor, what had happened, by changing the value of resistance also, we are seeing here the voltage across this Zener diode and this R3 resistance is not increasing. The reason is that the Zener diode has already reached around its breakdown voltage. So in this case we are seeing that the voltage across this R2 resistance is not increasing by much factor or at negligible rate. Okay, so this means that this Zener diode is acting as a voltage regulator. Now one theory is there, if I am going to change the resistance here, suppose there is a voltage here, okay, since voltage PR1 is in this side, so voltage PR1 is also present here only, okay, so there should be a current I, okay, since both Zener and this resistance R2 is in parallel condition, so the voltage across these two should be same always. Now if the resistance is changing here, suppose I am going to decrease the resistance here, okay, so current should be increasing here, okay, in order to make the voltage across this Zener and this R2 resistance same. Understood? So now what we are seeing, that after reaching the breakdown voltage, the voltage across this Zener diode and this R2 resistance is not changing. That means that this Zener diode is limiting the value of voltage in spite of increasing the value of resistance here. If we are going to increase the value of resistance, Zener diode, what it will do, it will decrease the current through this resistance, okay, and it will make the voltage across this resistance R2 same. Okay, so just see here, I am going to increase again the resistance here. Just see here, I have increased the resistance to 85% of 3 kilo ohm. I am going to again increase the resistance to 90% of it. Okay, so just see here, the voltage is not increasing here, okay, across both the this R2 resistor and this Zener diode. This means that resistance is increasing but current is decreasing here, okay, that's why this voltage is not changing. That means that yes, this Zener diode is acting as a voltage regulator. Understood? So for the third part, that means for this last part of this experiment, what we have to do, you have to firstly find out by the help of Excel sheet here that what is the approx input voltage at which the Zener breaks down, and then we have to add a resistance here, and then we will check that yes, whether this Zener diode act as a voltage regulator or not. So what you have to do, you have to run this simulation at the input voltage for which the Zener breaks down, and you will take 3 to 4 different pictures or just check the values of the voltage here, okay, and write it down in the Excel sheet that yes, at input voltage of 7.5 volt, this resistance value, whatever it would be, the voltage across this resistance and this diode is something like X or whatever it is, and then take 4 to 5 observations. Okay, 4 to 5 observation means that increase the resistance, okay, increase it in such a way that this Zener diode reaches its breakdown voltage. Afterwards take 3 to 4 observation of different resistors here, okay, in that thing you will show that yes, this voltage is not changing across the resistor. Okay, if you are going to take picture, it would be simple, okay, just take 4 to 5 pictures of different observations in which you are showing that we are changing the value of this resistor, and after a limit value of this resistor, we are seeing that yes, this Zener diode reaches its breakdown voltage, and afterward we are not getting any different amount of voltage across this Zener diode and this R2 resistor. Okay, So just take 4 to 5 observations of different resistors here to show that this Zener diode acts as a voltage regulator. Okay, and add those pictures at the end of your manual. Okay, so this is the final part of the experiment. Okay, I hope you understood that what you have to do. So thank you for watching.